Howdy, howdy, this is Mr. Potter. In today's video, we're going to be talking about how to divide polynomials from each other. In order to really understand this, though, we kind of need to talk about what division is. And so I want to talk a little bit about the division algorithm. So the idea is, let's say that I have 25, and I want to divide it by 3. The way that we would do this in our 4th grade class is we would do long division. We would have 25 being our dividend and 3 being our divisor. And what we'd have to do is we have to figure out what our quotient is by figuring a multiple of 3 that's less than or equal to 25. In other words, the largest one without going over. So I happen to know that 3 times 8 is 24. 24 is less than 25. If I go one more multiple, I'll have 27, which is too big. So when I subtract 25 minus 24, I get 1. So this gives me 8 with a remainder of 1. So what I've got here is that 25 is my dividend, and 3 is my divisor. And these are the numbers that I start off with. I always start off with the dividend and the divisor. The divisor is supposed to go into the dividend a certain number of times, and that number of times is called the quotient. But if I have anything that's left over, say this multiple does not go into my dividend equally, then whatever I have left over is called my remainder. And we're going to continue to use these terms, but we're going to be dealing with polynomials rather than numbers. So let's say I've got a problem like this. I want to divide this polynomial, x to the 4th minus 4x cubed plus 7x squared minus 9x plus 11. And I want to divide it by the monomial x minus 3. So again, I'm going to do this using long division. So I'm going to have x to the 4th minus 4x cubed plus 7x squared minus 9x plus 11. And I want to divide this, putting it under the vinculum here, by x minus 3. And so what I'm looking for is I'm looking for the largest multiple that's less than what I'm dealing with. So I happen to know that if I were to take x cubed and multiply it times x, I would get x to the 4th. And if I subtract that, then I wouldn't have any x to the 4th. My degree would decrease. So I know that my polynomial term would be at least one term less, because I'd be reducing it by a degree of 1. So if I take x cubed and multiply it times this monomial, I'm going to have x to the 4th minus 3x cubed. And then I want to subtract this polynomial from this polynomial. So if I want to subtract this, that means that I really want to make this a negative x to the 4th and a positive 3x cubed. Keep in mind that subtracting is really adding the additive inverse, or adding the opposite. And I'm going to add these together. So x to the 4th minus x to the 4th is 0. I'm not going to worry about writing the 0 here, but you know there's a 0 here. Negative 4x cubed plus 3x cubed leaves us with negative 1x cubed. And so I've got a monomial here, but I'm going to need to bring down this next term, 7x squared. So now I have a binomial. I've got 2 terms here, and I want to know how many times this goes into this. Remember, my coefficient here is 1. So I know that 1x times something will give me negative 1x cubed, and that something is negative 1x squared. So if I take negative 1x squared and multiply it times 1x, that's going to give me negative 1x cubed. And negative 1x squared times negative 3 will give me positive 3x squared. And again, I want to subtract this, which really means that I'm adding the opposites to it. So negative 1x cubed plus 1x cubed, that's going to give me 0. And again, I'm not going to write the 0. But 7x squared minus 3x squared gives me 4x squared. And I'm going to bring down the next term in my polynomial. Keep in mind that every time I'm doing this, I'm reducing the degree of this polynomial by 1. I start off with a quartic, then I had a cubic, now I've got a quadratic. So I'm going to need to figure out what I need to multiply 1x by to get 4x squared, and that's going to be 4x. So 4x times 1x will give me 4x squared. 4x times negative 3 will give me negative 12x. And I'm subtracting it, which means I'm adding the opposite. Of course, negative 4x squared and 4x squared gives me 0. Negative 9x and 12x will give me 3x. And I'm going to drop down this remaining term, my constant term, 11. And so now I'm going to need to figure out what times 1x will give me 3x, and that's just 3. So 3 times 1x is 3x. 3 times negative 3 is negative 9. And I want to subtract it, which means I want to add the opposites. And of course, this is going to give me 0. This gives me 20. So looking at this, my quotient is the polynomial x cubed minus 1x squared plus 4x plus 3. And my remainder is 20. And a couple of things that you really need to notice about this. First, when I'm dealing with this, the degree of the divisor plus the degree of the quotient should equal the degree of the dividend. So what do I mean by that? Well, when we were dealing with this, our divisor was x minus 3. And our quotient was the x cubed minus x squared plus 4x plus 3. Our dividend was our original polynomial, which was the x to the 4th minus 4x cubed plus 7x squared plus minus 9x plus 11. And notice that if I take the degree of my divisor, 1, and the degree of my quotient, 3, and add them together, I get 4. So the degree of my divisor and the degree of my quotient have to add up to the degree of my dividend. Second thing that I need to notice from this is that the degree of the remainder must be less than the degree of the divisor. So remember, our remainder was 20 and our divisor was x minus 3. This has a degree of 1. This has a degree of 0. And of course, the idea is that if I had, say, 20x plus 2, well, that means I could subtract this from it 20 more times to eliminate that term. So the idea is that I should be able to subtract this divisor a certain number of times to eliminate whatever that power is that's equal to it. So this degree of my remainder is always going to be strictly less than, not less than or equal to, but just less than whatever the degree of my divisor is. So in other words, I should be reducing the degree every time. If you notice in our problem, we went from x to the 4th to x cubed to x squared to x to the 1st to x to the 0. So the idea is that this should be reducing. And this is great. It's really easy to do as long as every term is represented. But occasionally I'll have problems where I'll have missing terms. So the idea, if I have missing terms, let's say that I've got x cubed plus 5x plus 1, and I want to divide it by the binomial x minus 2. Well, I'm looking at this, and what I really have is x cubed plus no x squareds plus 5x plus 1. In other words, I need to make sure that every term is included. So missing terms have a 0 coefficient. Have a 0 coefficient. So I'm going to divide this by x minus 2, and the process is going to be very similar to what we were doing before. I need to multiply times x squared to get an x cubed term. X squared times negative 2 gives me negative 2x. I change the signs on these terms and add. This becomes 0, which I'm not going to write. This becomes 2x squared. I bring down the next term, 5x. I'm going to need to multiply times 2x to get the 2x squared here. 2x times x gives me 2x squared. 2x times negative 2 gives me negative 4x. Change the signs and add. This gives me 9x plus 1. I'm going to need to multiply times 9. 9 goes into x, gives me 9x. 9 into negative 2 gives me negative 18. Change the signs, and I get 19. So my quotient is equal to x squared plus 2x plus 9, and my remainder is just 19. Again, notice that if I take x to the first plus x squared, if I take those degrees and add them together, that does give me the degree of my dividend, and the degree of my remainder is less than the degree of my divisor. So this is great. The process is not very elaborate. The process is very straightforward, but there's a lot of tedium here. There's a lot of writing stuff down. And the question is there an easier way to do this? And the answer is yes, if your divisor is of first degree polynomial. So this only works if the divisor is linear. So let's say that I wanted to do x to the fourth minus 2x squared plus 6x minus 9. And I want to divide this by the term x plus 1. Well, keep in mind that all that I had to do was I had to make sure that my degrees kind of stayed in their own lane. All of these in the same column have the same degrees. All I'm really doing is working with the coefficients. I've got a 1 and a negative 1. I've got a 0 and a 2 and a 2 and a negative 2. I've got a 5 and I've got a 5 and a 4 and a 9. I've got a 9 and a negative 9. This is a 1, 1, and 18. Second is because I'm constantly dropping down these terms, I don't really need to write this stuff lower. I could write it all in one line, just realizing, hey, this is always going to be 0. So if I was to do that, let's just write the coefficients down. So the coefficient of my quartic term is 1. The coefficient of my linear term, or my cubic term, notice there is no x cubed, so there's really 0x cubed. My quadratic term is negative 2. My linear term is 6, and my constant term is negative 9. And I'm going to be dividing by this fraction. Well, not this fraction, this polynomial here. But this polynomial really has a solution of negative 1. If I was to set this equal to 0, that would be my x-intercept. So I'm going to be using that value. I'm going to be using negative 1 in here because the idea is that I'm always going to want to subtract, subtract, subtract. I always want to subtract, so I want the opposite of whatever that value is. So the process is, notice of course that these terms here come from the coefficients of my polynomial. And this is always going to give me the opposite here. By habit, we drop this first coefficient. We drop the 1. And I'm going to take negative 1 times 1, and that's going to give me negative 1. And I add these together. 0 and negative 1 give me a negative 1. And I multiply. Negative 1 times negative 1 gives me 1. I add these together. That's going to give me a negative 1. And negative 1 times negative 1 gives me 1. 6 plus 1 gives me 7. And negative 1 times 7 gives me a negative 7. And I've got negative 9 and negative 7, which gives me negative 16. Now at this point, I'm not going to multiply negative 1 times negative 16 because there's no more terms out here on the right. But what's important for me to note is this is a degree of 1. This was a degree of 4. And we know that the degree of my quotient plus the degree of my divisor has to equal the degree of my dividend. So this has to be of degree 3. So this is my x cubed term. That means this has to be my x squared term. This has to be my x term. This has to be my constant term. Well, that means that this has to be my remainder. So in other words, in this problem, my quotient would be x cubed minus x squared minus x plus 7 with the remainder of negative 16. And yes, it is perfectly acceptable to have a negative value for a remainder. That negative value really is just the coefficient of the next power down. This being linear, being degree 1. The next term down would be a degree 0 term or a constant term. It's perfectly acceptable to have a negative remainder, and that's fine. Now, one thing I want to understand is that if I were to think of this as a function, f of x equals this, then what I'm really saying is that f of negative 1, in other words, if I substitute this value into my function, it's going to be equal to negative 16. In other words, whatever my remainder is, my remainder is the function evaluated at the divisor intercept. So that's really good. What that means is that if we go back to our previous problem, what I've got here is that if I were to take f of 2, that's the solution to this equation, that's got to be equal to my remainder, which is 19. And if I go back to the previous problem before that, if I want to take f of this, in other words, f of 3 in this case, is going to give me 20. So long division allows me to find a quotient and a remainder, but that remainder actually has some significance to us from an algebraic standpoint. It really is evaluating at a particular point. So I want to do one last example of division of polynomials because we've been dealing primarily where our divisor is linear. Well, of course, we're not always going to be dividing by a linear function. Sometimes we may divide by something with a higher degree. So let's say that I want to take x to the 4th minus 4x cubed, and I want to divide this by x squared minus 4. So I'm taking this polynomial with two terms, that's a 4th degree polynomial, and I'm dividing by a x squared quadratic polynomial. I see a lot of missing terms here. So let's flesh this out, okay? So I've got x to the 4th minus 4x cubed plus no x squared plus no x's and no constants. And I'm dividing this by x squared plus no x's minus 4. So again, just like we did before, I need to make sure that if I'm missing any terms in my polynomial expansion, if I don't have all of the degrees represented, I need to represent them with the 0 coefficient. And I need to go ahead and try and divide, figure out what multiplied by this largest degree gives me the largest degree that I have remaining. X squared times what gives me x to the 4th? X squared times x squared gives me x to the 4th. And again, as a matter of habit, I'm going to be writing the degrees in a vertical column, so all the degrees will match. So x squared times x squared gives me x to the 4th. X squared times nothing gives me no x cubed. And x squared times negative 4 gives me negative 4x squared. And I'm going to change the signs in all of these. So that becomes a minus, that becomes a minus, that becomes a plus. This is 0. This is negative 4x cubed. This is 4x squared. And I'm going to bring one more term down, this 0x, because my divisor has 3 terms. The term that I'm looking to divide into should also be represented by 3 terms. So I'm going to take x squared times what gives me negative 4x cubed. X squared times negative 4x would give me negative 4x cubed. Negative 4x times x squared gives me negative 4x cubed. Negative 4x times nothing gives me nothing. And negative 4x times negative 4 gives me positive 16x. And again, I'm going to change the signs, and I'm going to add. That's 0. That's 4x squared. That's minus 16x. And I'm going to drop the next term. So now, what times x squared gives me 4x squared? Well, just 4. So 4 times x squared is 4x squared. 4 times nothing is nothing. And 4 times negative 4 is negative 16. Changing the signs and adding gives me negative 16x squared, or excuse me, negative 16x plus 16. So looking at this, my quotient is going to be x squared minus 4x plus 4. And my remainder is going to be the polynomial negative 16x plus 16. And a couple of things we should recognize here. One is that the degree of my quotient plus the degree of my divisor has to equal the degree of my dividend. 2 plus 2 does equal 4 in this case. And second, the degree of my remainder must be less than the degree of my divisor, which it is. So both of these answers make sense in that aspect. I can always check my answer by taking my quotient, x squared minus 4x plus 4, and multiplying it times x squared minus 4. And if I add this polynomial, negative 16x plus 16, this should end up being x to the 4th minus 4x cubed, if I combine my terms correctly, and I make sure I don't make any math mistakes. I'm going to leave that as an exercise for you to work on. Once again, this is Mr. Potter. Thank you for watching. Have a great day.